In this video, we're looking at how the pressure changes as we go deeper within a fluid. So if we look at our formula here, P represents pressure. P by itself represents the pressure deep down at the bottom of a fluid. P with a subscript of 0 represents the pressure at the top. In other words, at 0 depth. Rho represents the density of the object. G, as always, represents the gravitational field constant, 9.81 newtons per kilogram. And H represents the depth, how far down in the fluid we go. So with the two pressures, P sub 0 represents the pressure at the surface, whereas P represents the pressure of whatever might be down at the bottom. Let's go through a problem together. Here we have a fish swims in a freshwater lake at a depth of 10 meters. Assuming that the atmospheric pressure at the lake's surface is 101,300 pascals, we want to know what is the pressure on the fish. So as always, we start with a diagram to see what's going on. We've got the surface of the water. We've got our fish over here. And we are at a depth of 10 meters. We're going to write down our givens. Now the pressure at the surface, that is P sub 0, that is the pressure here at the top, is 101,300 pascals. So that's P sub 0 is 101,300 pascals. Whenever a fluid touches the atmosphere, whenever a fluid touches the air, that is going to be the pressure at that location. Now, it doesn't look like we're given much else. We are given the depth of 10 meters. But we're also given a clue that it is a freshwater lake. And so you can look up the density of water. And the density of water is 1,000 kilograms per cubic meter. So that's just a value you need to know. Whenever it says about it being water, you should know the density is 1,000 kilograms per cubic meter. We want to know what is the pressure at the bottom on the fish. If we go to our formula says that the pressure at the bottom is equal to the pressure at the top plus the density times gravitational field constant times our depth. Pressure at the surface is 101,300. Density is 1,000. G, as always, is 9.81. And our depth is 10. Simply putting this into our calculator as we see it, we get a value of 199,400 pascals. I just want to point out this is almost double the pressure of the pressure at the surface. This is almost 2 atmospheres. And all we've done is gone down 10 meters, and 10 meters is about 3 to 4 stories deep, closer to 3 than it is to 4. So it's about 3 to 4 stories deep, and we've already doubled our pressure. And so pressure increases very drastically as we go further down in water.